The drilling location comprises two areas. One area which supports the drilling unit substructure and makes sense to include motors, generators, and mud pumps. This area is required to have high bearing capacity in order to be able to support the high loads and withstand the high vibrations. The second area is the surrounding area. This area is used for handling and storage of material and equipment, placing camps, bio-racks, and this area requires a bearing capacity equals to that of the access roads. Foundations may be required to ensure the safety of equipment in order to provide a stable leveled base for the rig up, including the mast erection. Support the rig or mast under the most extreme conditions of high hook load and the maximum amount of pipe racked in the rig. Provide support for heavy vibrating equipment. The foundation must be level and sufficiently large and strong to prevent the rig or mast from tilting or substructure from distortion. The type of foundation used depends on the bearing capacity provided by the ground itself and the time interval required for the drilling operations and re-entry activities. A solid ledge of hard rock can have the bearing capacity of the order of 50K to 200K psi. Meanwhile, soft, unconsolidated sand can have the bearing capacity of the order of 2K to 4K psi or less, in circumstances in which the subsoil is relatively weak, or the foundation is required to be in place for the lifetime of the field. A concrete foundation would be preferred. The foundation thickness depends on the type of the ground. If the ground consists of unconsolidated formation, such as soft clays, it may be required or may be necessary to drive piles into the ground. A common alternative in stronger grounds is to use wooden mats. In this case, the soft topsoil must be removed down to a suitable firm ground conditions. The hole made in this way is then filled with sand and called the sand bed. The sand is watered or rolled in order to compact it. Then the surface is leveled off before the foundation is installed. Mats are made of 3 layers of timbers nailed together crosswise. This will give you a total thickness of 9 inches, as each layer gives you a thickness of 3 inches, as you can see in the figure next to me. A new development is to use silicone mats. These are steel-framed reinforced concrete slabs with approximately 4 square feet and 3 inches thick, with a lifting point in the center for proper positioning by crane. This method is less expensive than permanent concrete or piling. Also, it can be used again and again on another locations and give you the ability to restore the location to its original state. This is all for now. See you in the next lecture.